Hello, this video is going to cover word problems with linear systems of equations. So my first word problem kind of came through weird when I printed, but oh well, it kind of squiggly. You'll see what I mean in just a second. So here's my first word problem. Make sure you can actually read it. Oops, and then I put this where you see words. Hold on. Alright, so this number one here. So this is a really common type of word problem. See, it kind of swiggled when I copied it. It copied weird. So during the 2009 Major League Baseball season, the Los Angeles Dodgers played 162 games. They won 28 more games than they lost. What was their win-loss record? So a lot of problems are like this, where they give you some information and you actually need to think of this as a system of equations. So let's think of we have wins and losses, so let's let W equal our wins and L equal our losses. How do you spell losses? Loses? That's not right. We'll just say what we lost. There we go. Okay, so wins and lost games. So these are the total amount of games that you won and you lost. So if you add all your wins and you add all your losses, that's going to give you the 162. So a lot of times people don't know how to separate that information. So your total games is going to be like W plus L equals 162. That's our first equation that we can get from this information. The second bit of the information will give us our second equation. They won 28 more games than they lost. So there's a couple ways that you can set those equal to each other. So I thought of it as if you take you know that you have less of the lost. So if you add the 28 to how many games you lost, that's going to equal your wins. Or you could have thought of it as your wins minus 28 equals your losses. So it depends on how you process that. But the 28 plus L would make those equal to each other to set up a second equation. So then I can use these two equations, and I'm going to use substitution method because this one's solved for W, and solve from here. So I'm going to move this up so I have room to solve. Oops, and that's still showing. So from here, I'm going to take this section and I'm going to substitute it in for W here so that I have L plus 28 plus L. So this L plus 28 is here plus the L equals 162. L plus L, still simplifying that left side, is 2L. Plus my 28 equals my 162. Subtract your 28 to the other side. Minus your 28. 0 here. So I'll have 2L equals 162 minus 28 is 134. Divide by 2. And your L, or the games that you lost, are 67. Okay, and then if I go back up, I know that my losses plus 28 would give me my wins, so my wins have to be 95. So do these add to 162? Oops. Do they add to 162, 95, and 67? Sure. So we know that we played the 162 games, so you're double checking your work basically. And that's how many games I lost, and that's how many games I won. Alright, so that was a basic one, but the one, and the work behind solving it's pretty easy, but a lot of people can't set up this first equation, or it kind of confuses them. So my next one is a percent per gallon one. Where did that go? Is it on the back side of this one? Is a mixture. These ones come up kind of a lot in one of my textbooks. Let's see. Okay, found it. All right, so number 17 here. All right, so we're going to kind of ignore the other portions of this one, like the 18 over here. All right, so let's look at what they give us here. How many gallons each of 25% alcohol and 35% alcohol should be mixed to get you 20 gallons of 32% alcohol? So we're looking at two different percents of alcohol, 25 and 35, to mix together to make 32%. And they kind of set up something here for you, but let's say we don't even have that, because on most of the work, when you go to do these out of My Math Lab or out of the textbook for a different class, you're not going to have any kind of help. So let me show you how this one would, you think through this one. Okay, so the first thought that I know of is I'm mixing two things. Okay, so I would think, well, I know that, let's let X equal the amount of 25% solution, and I'm going to, this is the amount, and I'm going to let Y equal the amount of the 35% solution. And again, you know that these two mixed together, they're gallons, so this is our gallons, our amount in gallons. I should add that on there, gallons, just so you know what we're looking for. So the first thing is to set the letters equal to what you're looking for. And then from here, I know that X plus Y have to equal 20 gallons. So each one is going to have to be part of 20 to make the total amount correct. So we know that. And we also know that X has 25%. So I used everything to do with gallons, the amount gallons. Now I'm going to do everything that has to do with the percents, and this is how I like to think of it. I know that it's 25% or 0.25% times my X amount is going to give me, so the amount of gallons times the percent, that's going to give you the percent of the total that you have there. And if I mix that with the 35% times the total Y, however much you have, it has to equal my goal. So you have percent times amount plus percent times amount that you're mixing. So you're adding them because you're mixing them, and your goal is 32% times my total gallons, which is 20. Okay, gallons, gallons, gallons. Percent, percent, percent. Always when you're mixing them, it's some kind of variation very similar to this setup. So I'm going to solve this, but I have X and Y in here, so I got to substitute. Substitution's probably the easiest way for this one. I was thinking about doing elimination, but because of the decimals, it's actually a lot harder. So what I'm going to do is just subtract over and let the X equal 20 minus Y. So I'm going to subtract the Y over on this top equation and let X equal 20 minus Y. Then what I can do is substitute this in for X here. Okay, so then I would have 0.25, the X is gone, and in its place I have 20 minus Y, plus my 0.35Y equals 0.32 times 20. Now I can simplify this and solve it from here. Okay, I gotta still out my calculator real quick. So start with 0.32 times 20. So 0.32 times 20 is going to give me 6.4. So it equals 6.4 simplified on the right. Now let's simplify the harder side. 0.25 times 20 is going to give you 5. So I have 5 minus 0.25 times y is just 0.25y plus 0.35y. So I can still simplify the left side. These are common, I can't even think, like terms. So I'm going to take 0.35 and minus off the 0.25 because this is a minus here. And I'd get 5 plus 0.1y equals 6.4. So all I did is combine the y's to get 0.1y, and it was positive, so you keep the plus sign there. Now move the 5 over by subtracting the 5 to the other side, and I get 0.1y equals 6.4 minus 5 is 1.4. Okay, divide 1.4 by 0.1 and you get 14. So 14 gallons is how much of Y you need. If you know they add to 20, you can take 20 minus your 14 to see that X would have to equal 6. So we know X is going to have to be 6 if Y was 14. Now let's go up and look at our answer that we got on this percent problem and think if that is a correct answer. Look back up. We're mixing 35% stuff with 25 to get 32. Which one would you have needed more of? The 35 that's close to the 32, and that's what we got. We got Y to be more, X to be less. So you should be the one that you needed the more of is closest to the percent you're looking at for the amount. So these are in gallons. So you have 14 gallons of the first one, 6 of the second. So that's kind of how a percent one works, and you'll run into a similar problem like that in a lot of them. So let's look at my last example. Oh goodness, I don't think I printed that one off to be able to read it easy. Okay, so what if we are talking about like the speed of a boat in a current, and you got distance equals rate times time? Those problems tend to really confuse people as well, so I wanted to do an example of that one. And let's see, so let me make sure this is the one I have. Okay. So hopefully I can get it to where you can see this one too. All right, so number 29 here is what I'm going to do next. So in his motorboat, Bill Rugberg travels upstream at top speed to his favorite fishing spot, a distance of 36 miles in 2 hours. So he went upstream in 2 hours. Returning, he finds the trip downstream still at top speed takes only 1.5 hours. Find the rate of Bill's boat and the rate of the current. Let X equal the rate of the boat and Y be the rate of the current. So they specifically tell us what X and Y have to be. And then I have to move, this was on a book, so I have to move my book to be able to show you the problem. All right, so we know that X has to equal the speed of the boat. All right, so Y is going to have to equal the speed of the current. So you have the speed of the boat and the speed of the current. Okay, so, and that was, they made us, use what they gave us. We know a couple things. We know distance equals rate times time, and that is kind of how the book walks you through if you push the example button and everything. The way I think about it is I know the speed of the boat and the current are connected by either the current helping your speed, making it higher, or making it less. So on this one, why did I close the book? Now I couldn't remember what the 36. Okay, so we went, all right, let's do this. This is how I think of it, upstream. For upstream, we know that the speed of the current is going to slow us down, right? So it's going to take our speed of our boat and it's going to subtract off our speed of the current. And that has to equal our 36 miles that we went divided by our 2. and I get the miles that I went divided by the time it took me to get that total there. And this is our rate over here. So rate times time, I kind of mixed it up a little bit. And this is kind of how I think through it. So I think, well, if I subtract those, I'm going to get my rate, and it has to equal the miles divided by my 2 here. So that's upstream. Downstream is kind of similar, but that the Y, the current, right, when you're going downstream, it's going to help you, right? It's going to speed you up. And that had to equal the same miles I went, which was 36, because both went 36, but it only took me 1.5. So distance equals rate times time. And I thought of this, and I went and divided by time. And I said, well, then the rate has to equal distance divided by time. So my rate is this whole entire idea, right? That's my rate, that's my speed. Rate's the same thing as speed, equal to distance divided by time. And that's where the idea of this came from. So that some of you might need to understand why. Once I saw an example written out this way, that made sense to me. So it kind of depends on you. But here's my 2 equations. Now I just need to solve them. So let's look at those. I'm going to move this down, or maybe over. So let's look at those. If we divide here, we would have x minus y equals 18. If I divide here, I'm going to have x plus y equals 24. So just dividing the 2 fractions of the distance divided by rate or time. Then I can see these are perfectly set up for the elimination method. I'm going to make this a big plus sign. X plus x is 2x. Negative 1y plus y makes 0, or they eliminate. That's why I picked this method. 18 and 24 are going to add to 42. Okay, divide by 2, and our speed of our boat is going to be 21 miles per hour. Then I can go up and I can put that back into either one. They have to add to be 24, and if this one's 21, then y would have to equal 3 miles per hour. And think about that. So x was our boat and y is our current. Well, clearly your boat has to go faster than the current, because if the current's faster than your boat, then you're not going to get upstream, right? You're going to float away and never get upstream. So there you go. There's the kind of walking you through a current in a boat in probably a little bit different way. But this one you have to think of upstream, downstream as your 2 equations that you set up separately from each other. All right, so those were the 3 very different word problems that I wanted to show you. And if I can get the video to stop.